This lesson is on mass of A to mass of B calculations. Remember, mass is grams of A to grams of B. These are three-step conversions. Now, the three conversion factors that you need, and this is their order they will come in, is molar mass of A. And remember, A is your known substance. You will always divide by the molar mass of A. The second conversion factor you will need is the mole bridge or the mole ratio. Remember, in your mole ratio, these numbers come from the balanced equation, and they have unlimited sig figs. Also in the mole bridge, moles of A is always on bottom and moles of B is always on top. The third conversion factor you will need to complete this calculation is the molar mass of B. B, remember, is the unknown substance, the substance you're trying to convert to. So you will have to calculate the molar mass of B, and you will end up multiplying by that molar mass. Let's take a look at the template, or how you would set this problem up, just focusing on your units as we look at our dimensional analysis set up here. So you would start with your given, which would be grams of A. The given would be grams of A. So you need grams of A to cancel first, which means you're going to get grams of A on bottom diagonal. This will be your molar mass of A. So you will want to calculate the molar mass of A using your periodic table. And remember, for molar mass, it's always grams per 1 mole of that substance. Next, you need moles of A to cancel. So you bring it down the unit moles of A where your mole bridge will go. The numbers for the mole bridge come from the coefficients in the balanced equation. Moles of B goes on top. Again, that number will come from the balanced equation as well. That gives you the ratio that these molecules are reacting in. Next, you need moles of B to cancel. So you'll put moles of B on bottom. This is going to be your molar mass of B, which means it's grams per 1 mole. Remember, molar mass is always grams per 1 mole, grams per 1 mole. Please don't use the mole ratio numbers for in the molar mass. The mole ratio takes care of the ratio here when you multiply and divide by the numbers from the balanced equation. You will notice that grams of A divides out with grams of A, moles of A divides out with moles of A, moles of B divides out with moles of B, and you will be left with grams of B, which is what you're trying to get. So let's look at a couple of examples. Now for these examples, I have already taken the time to balance the equations so that we can focus mainly on the setup and how to get these answers. So number 1, or 4 actually in your note, if you have your fill-in sheet, it's numbered number 4. It says determine the mass of antimony produced. So it's asking about, I want us to find the grams of SB. When 0.46 grams of antimony 3 oxide reacts with carbon according to the above reaction. So this is the other molecule they're talking about, the antimony 3 oxide. We do not need the carbon or the carbon monoxide to help us here. We just need to focus on the two molecules mentioned. So let's start with our given. Always start with your given, which is 0.46 grams of SB2O3. Now, it is definitely worth taking the time to write out the molecules' formulas because you are going to need the molar mass, and so that is what you use to figure out the molar mass, is that exact formula, SB2O3. Now again, we're trying to convert to grams of antimony, so I'm going to go ahead and come over here and put grams of SB because that's what I'm trying to find. Gram to gram is a 3-step conversion. So we need to get grams of SB2O3 on bottom. And again, this is our molar mass, so this will be 1 mole of SB2O3. I'll come back and get the molar mass in a minute. Now I need moles. Remember, focus on your units. Moles of SB2O3 on bottom because they got to exactly match unit and substance. Unit and substance. This is A. We're trying to get rid of moles of A, and we're trying to see what ratio it reacts with moles of B, and in this case, it's the antimony is our substance B. Remember, B is the substance you're trying to convert to. So this mole bridge lets us cross over to the antimony. Again, let's get our units in place first. So I need moles of SB on bottom and grams of SB on top. So this is our molar mass of antimony. And again, since it's molar mass, it's grams per 1 mole. Again, molar mass is always grams per 1 mole. Notice I have not looked at my balanced equation yet. I have not found any molar masses yet, but that's what we're going to do next. Now we're ready to put our numbers in. So let's calculate the molar mass of SB2O3. So using your periodic table, you're going to say 2 times the atomic mass of antimony. And so as I look at my periodic table, antimony is 121.76. And then the oxygen, of course, is 16.00. So as we calculate our molar mass, we get 243.52 plus 48.00. And when you add that together, you get 291.52 grams per mole. So this is going to plug in here. 291.52 grams per mole. Now let's get our mole ratio number. So the antimony, there's a 2. So this is where the coefficients come in only in your mole bridge. 2 moles of antimony react with 1 mole of the antimony 3 oxide. So here's where the mole ratio numbers come in. And now again, we're going to plug in the atomic mass of antimony because it's just antimony. So nothing to calculate here, just pull it from the periodic table, 121.76 grams. Notice grams of Sb2O3 divide out, moles of Sb2O3 divide out, moles of Sb divide out, and here. So now you're going to multiply. Now when you plug this in your calculator, do your numerator first. So just for this first example, here's what you should plug in. I'm writing it a little differently in case you're confused. So 0.46 times 2 times 121.76, that's your numerator numbers. And then we're going to divide by, the only numbers here in the denominator that we're dividing by is the 291.52. When you plug that in, we're going to round it to 2 sig figs. So hopefully, I'll give you a chance to plug that in. Hopefully you're going to come up with what I get. I get 0.38 grams of antimony. Okay. All right, let's go on to the next example. Now I'm going to kind of breeze through these examples. If you might want to actually pause the video and maybe try it on your own and then check just for understanding. So it says what mass of H2O2 must decompose to produce 0.77 grams of water. So they mentioned H2O2, so let's circle that. And they mentioned water, so let's circle that. So we're not going to do anything with the oxygen. So we're going to start with our given. 0.77 grams of H2O is our given. And again, we're trying to convert. What are we trying to find? Mass of H2O2. So over here, grams of H2O2 is what you will put there. All right, gram of A to gram of B is 3 steps. So let's get our units in place. I need grams of water on bottom. So this will be 1 mole of water because it's our molar mass. I'm going to need moles of water to cancel. So moles of water goes on bottom. Moles of the hydrogen peroxide goes on top, H2O2. That's going to be my mole bridge. Now I need moles of H2O2 to cancel and grams of H2O2 on top. This is a molar mass again. Molar mass is grams per 1 mole. Grams per 1 mole. So again, look at the pattern here. Let's find the molar mass of water and plug it in. So we have 2 times 1.01, which is 2.02. For the oxygens, you just have 1, so 16.00. So the molar mass of water is 18.02 grams per mole. So let's plug that in. 18.02 goes here. Now we move to our mole bridge. Look at your balanced equation. H2O2 has a 2 coefficient and the water has a 2 coefficient. So they're reacting in a 2-to-2 ratio, or really a 1-to-1 ratio, right? Now let's find the molar mass of the H2O2. So here you have 2 times 1.01 again, which is 2.02 again. And we have 2 oxygens here times 16.00 gives you 32.00. So that's going to give you 34.02 grams per mole for the molar mass of the hydrogen peroxide. So let's plug that in here, 34.02. This lets grams of water cancel, moles of water cancel, moles of H2O2 cancel. Grams of H2O2 is what you want, and that's what we got. We plug this in. So multiply 0.77 times 2 times 34.02 divided by 18.02 times 2. Now, one thing that I can kind of just share with you, that's something that I do sometimes, if I see where numbers are kind of simplifying and it will save me some buttons to plug in my calculator, I'll do that. So if you'll notice here, this is 2 divided by 2. It gives you a 1-to-1 ratio. That will actually save you some time. So you could just plug in 0.77 times 34.02 divided by 18.02. Everybody plug that in, pause it if you need to, and then check your answer. Give yourself time to make sure, just for understanding. When I plugged it in, I got 1.5 for my answer, and I did 2 sig figs. Let's look at one final example. So this says what mass of carbon monoxide, so we're looking for mass of carbon monoxide, which is here, must react with oxygen to produce 0.69 grams of carbon dioxide. So carbon dioxide. So we're not going to be dealing with the oxygen in this calculation. We're only dealing with 2 molecules at a time, remember. So 0.69 grams of carbon dioxide is your given. So always, always, always start with your given. We're trying to go to mass of carbon monoxide. So over here we want grams of CO. So gram of A to gram of B is 3 steps. Mass to mass is always 3 steps. So let's get our units in place. We need grams of CO2 on bottom. This is a molar mass of carbon dioxide, or molar mass of A, which means this is 1 mole of carbon dioxide on top. I need moles of CO2 on bottom, moles of CO on top for my mole bridge. Now I need moles of CO to divide out, grams of CO on top. This is the molar mass of B. So that means this will be a 1 mole there. Grams per 1 mole, again, grams per 1 mole. Molar mass is always grams per 1 mole. All right, carbon dioxide. So we have 1 carbon is 12.01. We have 2 oxygens times 16, which is 32.00. Adding that up, you get 44.01 grams per mole for the molar mass. 44.01 plugs in here. This will let grams of CO2 cancel. Now for the mole bridge. The carbon dioxide has a 2. The carbon monoxide also has a 2. 2 over 2. This lets moles of CO2 cancel. Now I need the molar mass of CO. So carbon is 12.01. Oxygen is just 16.00. So the molar mass of carbon monoxide is 28.01 grams per mole. Plug that in up top, 28.01. And that's going to let moles of CO cancel. Just like on the last problem, when I was talking about how you can simplify, notice the 2 and the 2 reduce out. That does not always happen, but it does in this case and in the last example, so this will save you some time. So what you're plugging in is 0.69 times 28.01, and then divide by 44.01. And we're going to round this to 2 sig figs, so if you plug that in correctly, you'll get 0.44 grams of CO. All right. So that's it for our lesson on mass-to-mass calculations. Now you should be able to easily do these homework problems that were assigned.